Nice.
Hey everybody, welcome to Startup Chuck. Today we are going to be trying to fix this Ryobi drill. It got left outside in the rain for, I don't know, a day or two, and then the brushes eventually got worn out really quick because of the rain rusting all of the motor and whatnot. Luckily for me, it may be the same motor that was in this Ryobi, portable bandsaw that I had bought years ago, and I tried to turn it into this sweet, snowmobile scooter that failed. Either way, I'm gonna rip the motor out and we're gonna see if it fits. It's a shame when you have a failed project and you put so much time and effort into it. This is another example of that. But silver lining being, hopefully I can salvage it and use the motor and fix this drill and have a third drill. You can never have too many drills. There's always a time where you need another drill. All right, let's see here. Sweet, keep that for later. Notice the crowned pulleys that I had in here to keep the belt centered. It's really neat how that works. All right, I got the motor here, so we can see whether or not its diameter is the same as the one that's in there. Offhand, it looks like this might be a little bigger, but we'll see. All right, we got this thing all separated. You can see here's the gear reduction module for the gearbox for that. Oh, I forgot that was a big spur gear. Look at this guy. Ha! Freed! Freedom! Huh, I must have made custom gears for that. Let's take apart one drill with another drill. Woo! Look at this thing. I don't know if that's grease or what. All right, here's the motor, and we are in luck. That looks like a direct replacement. So we'll just swap this guy out for that one. Should be good to go. Definitely gonna want some gloves. All right. So first thing we're gonna do, separate this guy out. Soldered on to this. So let's unsolder it. But for now, I'm just going to snip it. Look at all the smoke in here. I really like this drill because it had a bubble level, which the newer ones don't have for some reason. I don't get why. It's not like it's that expensive. Okay, if I remember this twist to undo. Nice. Okay, there's the whole planetary system. Here's my gear. I might not even have to undo anything if this other one twists the same. Ooh, it also twisted and came off of its planets. I'd be crazy if this goes straight in. Oh, this one had a longer shaft. This one didn't. Let's see if it works. Does not seem like it's apples to apples. Okay, so we'll undo these, swap the collar, and then probably SOL on the shaft length, but we'll see. Maybe I can do something. You know, I could just count the number of teeth and even see if it's the same number. That would tell me whether or not this is at least close. Let's look. This has seen better days. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, counted 12. And then this guy. 1, 2, 3. Might have 13. I don't know if this is going to fit. Let's do a quick check. Oh, it doesn't fit. It's so close. Seemingly almost identical motors. Different pinion gear there on the planetary system. So that's a bummer. I could, in theory, swap the shafts and then use the brushes from this new one. I mean, essentially that would probably destroy this motor. I'd have to pull these 4 tabs on the back, slip it out. Do I want to do that? Done something like that before. Motor windings, though, smoked, which means that even if I were to swap this, pretty sure the windings are toast on it. Well, let's pop it off and see if that's the case. Got the back off. Got the bushing off. Let's see if we can't get... The brushes actually look okay in this. I don't know if you can see, but the brushes look like there's some meat still left on them, so I don't think the brushes burn out. I think it was more the windings. So the brushes look fine, just really dirty in here. Alright, so that's not looking good for the motor here. We'll check the windings then on this and see what happened. So that means popping the shaft through that gear. Need my handy dandy. I got this hammer from like some road sale one time, and it was like the cheapest hammer ever. Oh, okay, that happened. Oh, interesting. The bushing just popped right out with it. All right. So, you know what? It looks like the bushings just fell apart, and then it just ended up arcing between these guys. And, just created a short. I wonder if I just clean all of it out, if it would work fine. Now that I've destroyed this whole motor, but maybe I can salvage it. I'd be super curious. That would be hilarious. Alright, I'll have to polish this guy up. See if I got a rag. This is interesting. So they balance this rotor by shaving away little bits of the laminations here, which is kind of neat. Pretty dirty. Oh, all my washers. I don't want to lose these. Oh, there's so many. I have no idea the correct order for these 4 washers are now. All right, the gap between what are these, armatures? I don't remember. Either way, they're full of carbon from the carbon brushes. So I bet you that was arcing. And that was what was preventing it from running. Okay. So a little bit of cleaning out. So in theory, every other side on this, and it looks like there's 6, should have continuity. So we can check that. Is it just me, or do you love when you test a multimeter and it goes beep? Yeah. All right. So one of these, ideally the one on the opposite side, should beep. Well, here, I'll test either of these two. Okay, they all beep. That's not a good sign. Okay. Why don't we clamp it? And then this will be easier. Okay, let's try it out. Okay, they're all fused, so that means the lamination's probably melted down, and this thing is now not separate in terms of its windings, so that's no good. Well, while we're here, let's see if we can't pop the shaft out of this, because why not? Getting there. Let's use a cheap screwdriver. Get it a little more. Ah. Getting there. All right, well, I got the gear on the shaft out. Destroyed the brushes though. Oh, let's saw it in half, see what it'll show us. All right, here's the stators. Kind of neat. I'm surprised there's so actual few copper wires for a motor. Couldn't have been very efficient. I had ripped that other one apart and was able to pop the shaft out. It's possible I could hammer on the correct gear onto here and put this guy on. Let's see if I can I do that? Is it even the same diameter? Before I go through all this hassle. .1955, .1955. Okay, same diameter, so that's a win. Okay. But if this doesn't hold the sun in the following motor, it's probably not going to work. I wonder if I can't just pound this whole shaft all the way through and push the other one out. Oh, I think it's going to completely destroy it. I could try. I'd have to remove these first, though. So this type of surgery is going to be super risky. I'm going to attempt to pound this through and replace the other shaft with this shaft. It's going to put a ton of load on this bushing down here, which is usually what destroys things. We're gonna find out. Alternatively, I could just maybe extend it by hammering this up forward, but then I think this bushing is gonna pop out here. So it's worth trying, I guess. Maybe I'll look and see whether or not I can get this replacement motor to put on there first, because I would like to keep this gearbox together because it's just so awesome. All right, we'll try that first. All right, so I separated out this shaft from the motor, and while I did find another motor that we could just replace it with, that seems super boring, so I got in my brushless motor. And so we're going to make this thing way more faster. So that'll be fun. Let's get going. So these are the same shaft size. So we got to get this gear off of here. I think I'm just going to tap it off with a hammer and a vise. We're just going to... Sweet. Let's save this 5mm shaft for something. All right, look at my pile of stuff. Right. Okay, so we got our gear. Okay, let's check and see whether or not the spacing on these holes is the same. So I've got 1.129-ish. And then, actually they're not. That is a problem. How am I going to make this work? Can I make an adapter? I wonder if I can recreate this on my 3D printer. I think we'll have to find out. Let's clean it up. Pretty clean. Now let's go measure it up. Get it modeled. So I got the adapter all modeled up and on shape, and then it was time to print it. We found out that this guy does not have the same bolt system as this one, and as opposed to having to make a new bracket adapter, we're just going to make a whole new bracket that'll then mount onto this guy right here, and so that we can then mount these two. But we got to get the gear on here. So where did I put the gear? Here it is. Okay, so let's support the drive shaft in the back here, so that way we don't actually jack things up, and hammer this guy on. How can we support that? I have ideas. Luckily, it's proud. Yep. Now we need something hollow to push it the rest of the way. Hollow like a nut. Whoop. Yeah. I think that'll work. Nice, although I think I might have put it too far on. 0.3 from the face. So, gotta go quite a bit off. Oh, that's not very on there. It's kind of concerning. Okay, seems good. All right, now I broke the wiper in here. So the question is, the new speed controller has a potentiometer on here to control the speed. And it only goes one direction. And to change direction, we would just swap with H-bridge 2 wires and it would change direction. So I need to replace this rotary potentiometer with a linear one that hopefully is in some sort of trigger setup. So I don't know how I can get a linear trigger setup going. Because like I said, I already destroyed this one, but we'll have to figure that out. These are all the parts from the inside of the switch mechanism, which was very complicated. So the wiper part, the one I actually wanted to keep, was right here, and it basically was, I don't know if it was a 10K or whatever, but it was a resistor between the two of them. So as you wiped the switch along it would change the resistance, and then it would change the pulse width modulation on the triac, and then that would change how fast your drill ran. But unfortunately, it was too hard to separate all this out with the whole thing just not exploding into a million parts, which then became super frustrating to deal with. So, oh well. I also wanted to use the switching mechanism to switch direction, but again, it blew up on me. Which, well, that'll happen. All right, we're trying my new camera. All right, so I've got my force sensor here, and it basically has lots of resistance, or doesn't even connect when nothing's touching it, and then a slight touch. And you start to quickly drop the resistance down to basically nothing. So I'm going to use that and basically put it in line with this guy. I'll put a 10K. I'll see what this resistance is, but basically throw a 10K resistor between two of these leads and add this one on the other side, and then it should give me full power whenever I press the trigger, and then very slight power adjustment based on a light touch. All right, so let's see, I've got my motor. I got my 3D printed adapter bracket. We're gonna get this guy to attach to the gearbox. There we go. Low if it's like that. Okay. So this guy gets switched. All that grease. So much grease. Alright, so it's forward. I don't need the reverse switch anymore. It's not there.
Okay. Yes, yes. Great. It's the motor. It's gonna mount in here like so. I want it to get routed through. So we're gonna know this. It's gonna mount to that like so. Got Okay, moment of truth. Nice. Ugh, my hands are covered in grease, so I need a rag. If you don't have a massive rag pile, then get one, because you always need rags. And in particular, socks always work really well. This guy is going to go right here. And then I need to get rid of that. Can I get it to close around it? Let's find out. Okay, we're looking pretty close. Yes. I think it'll seal up. Pew pew. Okay, that fit. Something like that. Directional switch. And we got our power knobber. What do we want to call that? Pressure switch. This will go here. And somehow this will connect. So in order to get the motor to reverse, basically I need this switch. I'm just going to swap 2 legs of this brushless motor. And the way you do that is essentially you connect diagonally these corner points, and then you connect either the motor to each leg, or you connect the speed controller to each leg. It doesn't really matter. As long as every time I switch this, it's going to switch whether or not this leg is connecting to the middle or whether or not this leg is connecting to the middle. And that'll work great. So I'll solder that up and connect the battery, and then we'll see how this thing works. Okay, so I just pulled off these 3 insulated covers, and look how bare the wires are at the ends there. So I'm actually going to put them back. Alright, moment of truth on whether or not this bad boy is going to spin. Got my battery right here. Gonna hook this thing up. Plus. Magic smoke, hope not. Nice. Okay, so this guy works. Awesome. Now let's figure out this potentiometer and figure out how to modify it. Alright, so we've got 12K. So the basics of the circuit are pretty simple. Basically, for the reversing switch, we've got a double pull, double throw switch, and it's break before make. So in other words, it won't connect until it's fully over to the other side. It'll disconnect one side before connecting to the other side. And you want that because otherwise you're going to short circuit your speed controller. So I'm going to tie the two center legs of the speed controller in the center here. And then I'm going to tie two legs of the motor to each of the two legs that I'm going to cross over. And then whenever you flick the switch, it'll either have these two legs connected to these two phases in this direction, or it'll flip it. And then the last leg just gets connected directly. So that's pretty straightforward. For the speed control circuit, I used to have this pot, and it was varying the resistance here connected to this red line. Now I'm going to replace that with a 10K. This was a 10K pot. So I'm going to have a 10K resistor, and then basically have my press sensor variable resistor here. And then this voltage will shift based on the pressure I got here. I'm not sure exactly which line it needs to be, whether or not yellow needs to be on this resistor or over here, but we can just swap it in either case. All right, so let's get that wired up and test it out. I don't know if this is going to be right or not, but we're going to find out. Worst case, it goes really fast. All right, I have done this backwards, but I'm able to get the modulation I want. So I need to switch these leads, which means that I need to have this be brown and this be yellow. Yellow, red, brown, brown to the 10K. All right, we'll flip this guy around. Got this thing switched around. Let's try it out again. Success so far. Okay. Let's do a good job on this thing upstairs, shall we? Before we do that, maybe we should print a little 3D printed block where I can fit both of these side by side. And then it can fit inside the switch housing here. All right, so I printed this cool little block, and basically it's gonna hold my direction switch, which I got right here. There we go. And it's also gonna hold nice my little pressure switch right here. It's routed along the side, and then it's going to mount right in there just like that. Ta-da. All right, so let's glue this guy on. Okay, let's glue this guy on. Hot glue. Yeah. Okay, that worked really, really good. All right, well, we're in my basement shop. It's loud. The furnace is right next to me. This is where I do electronics. Mainly just because this is where I had my first little bit of space when I was working on the house. But either way, this is where I solder a bunch of stuff, and so this is where we're going to be soldering up the drill. All right. Let's redo all these joints that are pretty suspect. Okay, some tools that I really, really love. One is a soldering iron. It's a TS100. It's pretty awesome, super tiny, runs off of either a 3 amp, 24 volt power supply, or you can even run it off of RC lithium batteries. Other thing that I really love is this mini air gun, hot air gun. This one's an HG350. It's not a lot of power. It's only about 350 watts, which is perfect.
It works really well, basically to heat things you want to loosen up, like with glues or especially heat shrink tubing, and you don't have to worry about getting anything too hot. Either way, super tiny and fits on the bench nicely. Totally recommend it. Another tool I love is this guy. It is a wire stripper and snips, although I've destroyed the snips over the years. But the wire stripping part works really well. It basically just pinches, pulls. I mean, I love how compact it is, and it works on a lot of different sizes. Now, when I need a resistor, I just go to my big box of resistors. You don't have a big box of resistors? Come on. All right, orange, black, brown, where are you? That's not it. Oh, that's 150. Ah, big bag of 10K right there. All right, brown, black, orange. If you don't own a hemostat, super useful. Watch this. Nice. Nice. We are all done now. Would you look at that? I left my hot glue gun on for 40 minutes and it's still going, so that's great. Although it looks like it's gonna die soon. Alrighty, so this guy's all ready to go. Let's test out and make sure it works before I put it all in there. I think it will. This guy's gonna go up there like that. Okay. All right. Plus moment of truth here. Now on a normal one, the switch is tapped over towards the left when it's going clockwise, which means that this is going to have to get mounted up in here like so. Let's try not to break anything. Let's mount it all back in here. Okay, let's get the hot glue out. We're just going to hot glue the crap out of this thing. Now that we got it all fitting in there barely. Let's see if we can get the case to start going down. Oh yeah. Oh yeah. It's looking really good. I think we're all together. I think I gotta use the weakest setting so I don't strip out these screws. Yep. Sweet. Can't believe this guy works. All right, let's add a lot more hot glue to it. More hot glue. I just finished installing the brushless motor and the speed controller and the pressure sensitive switch into this old drill. It now is spinning crazy fast. You know, clearly I could change the motor. I could change the voltage on the speed controller and all of that, but reality is that I want to keep using the batteries that we have, and so we're gonna use an RPM tachometer. We're going to figure out what the top RPM is of each of these drills and get a general idea of how much faster this guy is than the old one. Shouldn't be that much faster, but let's find out. I got my reflective flag on here. I've got my meter, and so let's see what we get. All right, 2000 RPM. So I think the original rated RPM on this was 1300. So we're quite a bit faster. Now, I'll test this guy out. Got my flag. So this one I was getting 1700 RPMs. So this guy's only about 300 RPMs slower than this guy. So let's drill some holes and see how it handles. Oh, it doesn't fit. Turns out this guy's got a smaller chuck. Let me get a different bit. All right, so that was full speed, and it didn't seem to bog down at all going through hard walnut with this drill bit. So let's try the other guy out and see whether or not I'm just blowing smoke or if that thing was pretty awesome. All right, the first test going through hardwood, I really think that my brushless drill worked a little bit better. It could just be that it was faster, but it just felt like it had a little bit more power and it just had no problem going through it. Who knows if it's the RPM, but the fact that it's spinning even faster, I'd expect it to bog down if I had a weaker motor. It's a pretty big motor in there. So overall, pretty happy. Let's try drilling through some aluminum and see if we can notice any bigger difference with some more load on there. All right, let's give this a shot. Might have killed the drill bit. I'm gonna get a different drill bit. Try again. All right, that's pretty good. Didn't stop when it went through. Try round two. Alrighty. Ugh. All right, so what's my takeaway? Well, this thing is pretty badass. I can't believe it worked. I really was going into it with that I was going to throw it away and it was scrap. You know, I could have swapped out the motor for a regular one, but this is way cooler. The fact that I can lightly put my finger pressure on it and get it to move very slowly and that it has a slightly higher RPM on the low setting when I'm drilling metal, total win for me. Because I don't know about you, but I feel like whenever I'm drilling metal, the low speed is too low and the high speed is too high, and it's never quite what I want for drilling aluminum. And I mostly work in aluminum, so I'd much rather have something that I can go a little bit quicker with, but not too fast. And this is it. So I will definitely keep using this thing and keep testing it out, and hopefully it doesn't burn out. We'll find out. The speed controller was only rated for 18 amps. I don't know whether or not we're overtaxing it or not. I could get a current meter on there, I suppose, but as of right now, I'm pretty thrilled. I don't think anybody should make one. I think it's kind of a waste of time. You can just go buy a brushless screwdriver, but actually, that's not true. To be fair, I own the brushless version of this, and if you start it up under torque, it will not start as easily. Because it wants to basically like see the, I don't know if it's sensorless and it needs to see it moving or whatever, but it has a harder time starting under torque. Don't know why. This thing, seemingly, no problem at all. Tons of torque. So I'm a big fan. Plus, now I got the drill. It's got the magnetic plate back on it, which I actually really love putting screws on there. So 2 thumbs up. Please like and subscribe, and I'll see you guys next time. Thanks.